Okay, good evening everybody. I think we are live. And good evening from a beautiful Death Valley late winter, early spring evening. Got some really nice weather here. It's getting up into the 70s now during the day and starting to warm up here in the desert already. This is kind of March is kind of our nice month of the year. So we are starting to get warm and comfortable here, and the nights are starting to get less freezing, which is nice. But we got a nice clear night. There may be a few wispy clouds flying around here or there, but for the most part, it's just going to be a really gorgeous evening. So, welcome everybody. My name is Mike, and I'm going to show you some interesting things in the sky tonight. Hopefully we're going to start off with some pretty spectacular stuff in Orion and in the area of Canis Major in our high in our southern sky right now. But first I want to start off by showing you, let me get this test pattern off here and show you first my setup. So what I'm going to be using here tonight. I apologize for this picture. It looks a bit blown out. It did not look this blown out on my other computer, but anyway, this is the telescope that I'm using tonight. This is a 6-inch f4 imaging Newtonian telescope. It's a reflector telescope, and you can see up here is the focuser, and this is where the camera gets stuck in, or the eyepieces if you're doing visual. But for me, for us, we're going to do some imaging so that you guys can see what I'm seeing. And tonight we're going to be using the ZWO ASI 533 camera, the color camera tonight. And the whole thing is being run on a Celestron Evolution AltAz mount that I have placed on something most of you who've been here a few times will notice, a new wedge. I was able to pick up the heavy-duty Celestron wedge off the used market and replaced my homemade wooden one. So I have like a real full-on professional wedge here to keep everything riding smoothly and hopefully be nice and strong. The old one was good, but it was a little bit small for what I was using for the stuff that I have riding on it. So this was a nice upgrade for me, and will hopefully keep things even more steady as we do some imaging. And I have the whole thing riding, of course, on my spare, no-expense cinder block pier, where all of these blocks here are glued together, but they're not actually glued to the cement pad that it's sitting on. And I'm now sitting behind this computer right here at this table, speaking to you. So that is what is being used tonight to capture our goodies. And started off on Sirius here, so Canis Major. This is where we spent a little bit of time last month focusing on a couple of these things. Just mostly star clusters and things that are in here, and a couple of galaxies as well. So I thought maybe I'd just zip up into here and see a little bit of nebulosity to start off with tonight. Now I am using, and it's I'm having some issues with it. Let's see if this runs. Yeah, obviously I'm getting these error messages which are not supposed to be here, and so it's not exactly working the way I was hoping. For some reason, some bugs have been reintroduced that he got rid of a couple of months ago, and suddenly they're back. So I may have to do a bit more clicking and mouse pointing tonight than normal, but should be able to still see some pretty cool stuff. So we've got some nice nebulosity in here. In fact, I think I'm going to come out into here. I believe we actually saw this last time. In here, and yeah, I'm pretty sure that's there. So okay, maybe I'm back. I think maybe I'm back. I apologize, I seem to be having network problems tonight. For some reason, my broadcasting software, OBS, continues to lose the network. I'm not sure why that is, but it is continuing to lose the network. It seems to be stable now. I guess I'll have to keep my eye on it. Well, anyway, while I've been struggling trying to keep my network up, I have been collecting some data here. So we have about 7 minutes of data collected on this particular image here. So let's see. I think we're all good here. Yeah, I have an excellent connection, so everything should be good. I'm still seeing an hourglass here on the I'm not sure why I'm seeing an hourglass here on the feed itself, but I think we're back. Although the network seems to be up and down and up and down. Well, the joys of working in the middle of the desert, I guess. Anyway, seem to have some stuff showing up here, so let me just keep working on this. I'm just going to assume my connection is going to stay up. And we'll just keep crossing our fingers here, but the network is definitely doing wonky things tonight, so I'm not sure what is going on with it, but it seems to be kind of all over the map. Thanks, Jeff. Good to see you. Thanks for stopping in. For those who just showed up, the first 10 minutes here have been an interesting exercise in trying to get my broadcast software to reconnect, because it just plain disconnected. So having some network problems here. So things seem to have stabilized, so hopefully we'll just keep rolling here. Okay, so let's see, where are we? So yeah, so here we have, we're in this little area right here. I believe this was, gosh, we just did this last time. I think this is the Pelican. It's called the Pelican, where the whole thing is kind of the head and the wings. So we did this last time, so I just thought I'd kind of warm up here a little bit with this, and then we'll continue moving north into Orion, where we're going to see some really cool stuff. Hopefully, if my network stays up. But some really pretty stuff is in here. Let me zoom in and kind of check that out a little bit better. Yeah, it seems to be still up. Okay. For some reason, when I'm looking at the feed, it looks like it's continually hourglassing again, even though it indicates it should be good here, so I can't tell what you guys are seeing. Hopefully you're still seeing what I'm showing you here, but I'm just getting a bunch of hourglassing now. So well, we get about 10 minutes on this, so I think I will let's try moving on here. And because we did see this last time. So it's a good warm-up, but I think at this point we'll just move right on up into next target 533. Okay, and now I have to manually move this since my sequences are not working. And let's go ahead up a little further here. Yeah, let's do Running Man. Coal car cluster. Alright, let's move right up into Running Man. Lots of pretty stuff to see up here. Good, I'm glad to hear it, Jeff. Things are really definitely wacky here, so I'm glad to see that it's not, hopefully not affecting the stream, because it's definitely doing weird stuff here. So this is just going to be, this is the basically the upper part of Orion's sword, which is this cluster up here. It's called the coal car cluster. It's also called Running Man, and you'll see why for that in a minute. But let's go ahead and reload our sequence and start capturing some data on that. Hey Pete, thanks for stopping in. Good to see you. Hope you guys are doing well over there in Utah. Out here we've got us a gorgeous night, so the weather gods have smiled upon us tonight. We've got some nice stuff here. Let me pull up my Wikipedia. NGC 1981. Yeah, see now this computer is claiming that there's no internet access. Just some really weird stuff going on with our network tonight. So may have to endure some oddities. But there's some nice nebulosity, so it'll be worth it once we get it all sorted out here. Let's back off a tiny bit on the stretch. But you can see it's a pretty nice cluster already starting. And down here is M42, which is the big, spectacular Orion Nebula. And we'll look at that here very soon. Evening, Joe. Thanks for stopping in. So this is called the Coal Car Cluster or the Running Man. It's a pretty cool, and basically it's the upper star in the sword of Orion. So in Orion, the big famous winter constellation, everybody can find Orion and the 3 stars in the belt, and then the 3 stars hanging down from his waist are the sword. The middle star is not a star, it's actually the giant Orion Nebula. The upper star is actually what we're looking at right now. A couple of interesting things right in there called the Coal Car Cluster, or it's also called Running Man. The Running Man, because if you look at this on its side, is a little bit of a running dude in there, like a guy who's running. But this is all a large area of star formation. The Orion Nebula, this whole area near all these nebulae, it's a very active star formation area in the Milky Way. And so these are all, which is why these stars are bright white and blue, not a more yellow and orange, which would indicate an older star. These are nice bright blue young stars that have just been formed in this area and are starting to move out into the universe. So, let me turn some music on here. See, and I did turn this up a bit too. Turn the levels up just a little bit, so you guys can let me know if it's too loud. But listening to my last stream, it just seemed to be it was a little bit too faint in the background. I couldn't really hear it. I like it being a nice background music, but I also would like it to be heard too. It doesn't need to drown me out, but hopefully it can be heard pretty well. Yeah, I'm definitely seeing the network indicator on my streaming software definitely going from green to yellow to red to yellow to green to yellow to red. It's just kind of going all kinds of wonky. So maybe a little bit of a challenging network night, but I'm glad to hear you guys aren't really seeing, you're not seeing much buffering or anything, so that's a good thing. Now let me see if I can do a little histogram adjustment on here and maybe clean up the color a little bit. Dink. Yeah, that's probably about right. Pretty star formation area. In fact, my second computer that is monitoring the stream is also constantly dropping the network. So, and I know my router is solid, so for some reason everything is just my ISP must be having problems or something tonight, because it's kind of going crazy. Oh well. In this case, I'm doing 60-second sub-exposures, which is probably a little bit much for this area. I should probably reduce that down a bit, but it definitely is a pretty area. Pretty area of the sky. The whole Orion complex, as it's sometimes referred to, is it's still looking okay. Good. The whole Orion complex is a huge area of star formation, and a lot of nebulosity, a lot of really young hot stars. So good stuff in here. What I might want to do actually is drop the exposure time down. Let me just try backing off on the histogram adjustment a little. Maybe that'll just make it pop a little bit better, because you can see there's channels in here of dark dust and things. It kind of makes the shape of a person running if you kind of look sideways at it. But this is all within a few thousand light years of us, so it's also fairly close. So that is right here. So what we're looking at is right in here. Top star. or the top cluster of stars actually, the top quote-unquote star in Orion's sword is a cluster of stars. And so we'll keep moving down here as we go. And I can't tell if... Right now my chat is blank, so I'm just assuming that's because I had to refresh my page, because my second computer also keeps losing internet connection. My signal strength is solid, but the connection to the internet keeps dropping, so there's something going on with my ISP. But my chat box is now blank, so I can't tell if that's what's going on there. Hopefully, I'll try refreshing my second machine again, see if it comes back. There we go. Hey, and I've got my chat back. Hello, Pimal. Glad you could finally join me. Good to see you. I am definitely having some... I'm doing better than last session, when I was 10 minutes late getting on and had all kinds of frustrations. Tonight I've merely had to uninstall and reinstall a piece of software while I was trying to align, and I'm having network issues. But other than that, everything is going well. For some reason, SharpCap tonight, I'm on the beta 4.0 version, and it just decided to start throwing up on me, so I tried doing a repair and that failed, so I had to completely uninstall and reinstall it. So tonight has not been without its challenges too, but but it's worth it because we're here and you guys are telling me the connections are still good, so that is encouraging. Oh, okay, good. Thanks for being here, Christina. Hopefully you're getting some good extra credit for being here. But so this is the Running Man or Coal Car cluster. And this is basically the asterism that is kind of the top star, quote-unquote, in Orion's sword, right here. And because this whole area, the entire Orion complex, is an area of lots of very active star formation. And so there's a lot of really young hot stars here and a lot of gases left over that still hasn't coalesced yet and formed stars of their own. So it's just a very cool, bright, pretty, flashy place to do amateur astronomy. So it's and in the winter time, it's the most spectacular constellation in the sky. So so now I think we'll just keep moving south, and we'll move into the big one, which is the Orion Nebula, M42. So the middle star. Okay, let's turn the stacking off. I now have to do all of this manually because my sequences aren't working. Next target will fail, but at least it will stop things. So now we'll keep moving south. We'll keep dropping down into... So we did kind of this stuff here already. So now we'll move down right into the heart of the matter, which is M42, or the Orion Nebula. The Great Orion Nebula. And you can already see it's showing off right there a little bit, even at the very small exposures. Let me try moving the scope into... okay, that was the wrong way. Move the scope. And see here, I'm getting these weird error messages. Don't know what that's about. Again, I'm having trouble with this beta. The older versions of the beta software I did not have any trouble with, but this one seems to be giving me all kinds of trouble, this latest version. So, see, I'm getting all kinds of error messages. Not sure why it's doing that, but oh well. Beta software. Let's move it up just a little bit more. move it over just a little bit more because it has a lot of tendrils that really flow out and around. Okay, so I'm going to we'll start with the sequence here, but I'm actually going to back off and well, you're gonna I'm definitely doing a live session. I do them fairly regularly when I can. Tonight is I'm going to drop to 15 seconds. I'm going to back down on the exposure because, maybe let's do 30. I'll do 30 seconds, which means I'll have to go to a new dark here. That'll be close enough. I definitely do these sessions every now and again, weather permitting. Hopefully I get a few in a month. But let's restart this since we started off with 60 seconds and now we're going to 32. I enjoy doing them, but it does have its technical challenges, so yeah. So we've got even a little bit of the bottom part here. Okay, let's bring this out here and bring this in here, and we can see a bit of the splendor of the Orion Nebula. Again, an area of very active star formation. In the center here, which you can't see very well because I have the exposure turned up in order to see these beautiful faint tendrils that come around it. In the center here there's a nice cluster of stars. It's called the trapezium, and one way you can test how good your refractor is to actually see how many stars you can split in the trapezium itself. In this case I have the exposure turned up so that we can see kind of the full extent of the nebulosity. It goes out for quite a ways out into here, but in doing so, to see the faint stuff, it completely blows out the inner core. So what I'm going to do is play around with this a little bit, and we will do some exposures that are longer exposures where we can see really the outskirts of things nicely. Take a few minutes doing that, and then I will continue to decrease the exposure and watch all of the nebulosity shrink, but then we'll be able to start seeing some of the center stars. Yeah, that's a good point, Pimal. I think what I'm going to do is I'm going to actually, I will show again the setup that I'm using. Here's what I'm using tonight. It's a 6-inch imaging Newtonian telescope, which is a reflector telescope. And here is where the eyepiece goes in, and instead of putting an eyepiece in, I'm using a digital camera. In this case, a ZWO ASI 533 camera, which is a color camera, a color astronomy camera. And that is what we're taking the pictures through. And it's running on an AltAz mount, a Celestron Evolution mount on a wedge that's polar aligned, so that the mount just needs to rotate one direction in order to be able to track the sky very accurately. And so that is how we are getting these pictures tonight, is through that scope and the camera. And this is the big winter show, M42. I'm going to stretch the heck out of it a bit more so we can really start to see some of that outer nebulosity a little bit better. You can see how far it extends out from the core of the nebula itself, which is up here. But there's a lot of dust and gas that's in this region that is doing star formation. Like I said, we'll take a few minutes doing this, really let some of that some of this outer wispiness come in. You can see kind of the full extent of it. And then we will stay on this target for a little bit, and I'll continue to decrease the exposure as we go along. And the outer parts will fade away and darken, and we'll start to see more and more of the core itself. But for now, you can see we got a little bit photobombed by a satellite down here that kind of buzzed through. And if I keep stacking for a while, that eventually would fade, because the newer sub-exposures that are coming in would eventually wipe it out. And I should probably explain that too. The software that I'm using is called SharpCap, and what it's doing is it's taking the exposures from the camera. In this case, I'm using 32-second exposures, or 30s. And it takes an exposure and plops it down, and then takes a second 30-second exposure, and it uses the background stars to align the second exposure with the first, and it plops it down on top. And takes the third one and does the same thing, uses the background stars to align it and plops it on top. So it's what's called stacking. And what this does is, with each subsequent sub-exposure that is stacked on top, the software knows, okay, so this area, this pixel here in the image was dark in all these pictures, so continue to make it darker. And this pixel was light, so continue to make it lighter. And so with each sub-exposure that is layered on top or stacked on top, the signal-to-noise ratio increases. The bright spots get brighter, the dark spots get darker. A lot of the noise and speckling goes away, and the image smooths out. And and it's a very clever alternative to astrophotography, sort of. It does not replace astrophotography, certainly, taking really long exposures on an object. But it's a way to kind of use technology to get almost astrophotography quality photos in much less time, using much less expensive and complicated equipment to do it. The setup that I just showed there, this is not very expensive stuff. Everything in there is less than $1,000 basically. The wedge, scope, and mount. On the used market, I paid less than $1,000 for, or probably about $1,000 for each of all of those things. Whereas in an astrophotography setup, you really need a very good mount, a very good way to drive your telescope with very extreme accuracy across the sky for hours at a time, if you're going to just spend hours at a time on the same object and hold your now virtual shutter open for minutes or even hours at a time. You have to have extremely accurate tracking, and those mounts cost many times what I paid for my entire setup. So with doing this stacking, or what some people call electronically assisted astronomy, you can get some really nice images without having those very high level requirements and very expensive hardware to do it. So it's a wonderful alternative, and it allows us amateur astronomers to see the kind of things that only professional astronomers have seen for years. And another really cool bonus is, because we're doing it all on our laptops that can be networked, it gives us the opportunity to share it with others. So it's kind of a win-win. It's a very nice nice benefit. So but there we are. So we're at about 8 minutes of, this is 8 minutes of data collection, 16 30-second sub-exposures. And that is M42 in all of its splendor. Again, a very spectacular area of star formation. In quotes, of course. it's about 1,300 light years away. So it's pretty darn close to us, which is why it's so big, bright, and spectacular. And it's the closest region of massive star formation to Earth. It's estimated to be about 24 light years across, and has a mass of about 2,000 times that of the Sun. So 24 light years across. It's quite a big deal. But it's a beauty. So Carrie asks, can I make the trapezium stars come out? Well, interesting you should ask that, because this is what we're going to do here over the next little bit, is I'm actually going to just stay on this object, and I'm going to begin reducing the exposures on the camera. And as I reduce exposures, the outer faint wispiness is going to disappear and the inner stars are going to show up. So that's what we're going to be doing next, Carrie. So just hang out, and we'll be doing that. So there is the 30-second exposure. Normally I do 60-second exposures for most things, but you can tell even at 30 it's a lot. So 60 would just be way too blown out. But now what we'll do is we will head for 15. So let's turn the stacking off. And let's see, I think I have a dark for 16, not 13. Yeah, let's go to 16 seconds. And we'll go to 16 here. Boink. Yeah. Okay. And now we will restart our stack. Clear the 30-second one out, and I realize I forgot to set some of my enhancements, which help sharpen things up and make them look a little better. Okay, and you can already tell, even though I don't have the histograms way out of adjustment, but you can already tell how much smaller it is, because the shorter exposures are not going to catch as much. So let's move this into here, and move this into here a little bit. And you can see, in this case, we haven't really lost a whole lot. It is a little bit smaller, and we'll let it run for a few seconds on this. But it's we haven't really lost a whole lot. And part of that is due to my camera, which is a great new technology CMOS camera that has a lot of sensitivity, has a lot of dynamic range. So it does actually a pretty darn good job getting both light and dark detected. So not a major difference here. There's definitely some of the outer parts are darker. They don't jump out nearly as much. But and you can tell the core is not quite as big as it was. It's a little bit more reduced. You can actually see some of the stars that are inside a little bit better. But so not a whole lot of difference here, but some of this structure up here, let me get the software out of the way, but you can see some of the structure up here is a little bit darker and a little bit more detailed, just because we have a little bit less blown out on it. And we'll let this go for a couple of minutes, and then we'll drop it to 8 seconds. And then I expect some of the outer stuff will start going away, and this core in the middle will definitely start shrinking down. And we'll just keep reducing our exposure times down until we really catch just the core stuff. Let me check and see how my check real quick and see how my network seems to be doing okay. This happens every now and again, where I will, the beginning of the night somehow seems a little squirrely, and then everything kind of settles out. So, don't know what that's about, but anyway. Need a drink. Yeah, some of these lanes up here are definitely darker and more structured. They pop out a little bit better because they're not quite so blown out with the longer exposure. So a little bit more detail up here. The furrows in the clouds are a little bit more pronounced. And like I said when I described the stacking, the more sub-exposures that I bring in, the more details sharpen up. And of course I also turned my enhancements on too just now, which I didn't have on for the 30 seconds. So that actually also is playing a role in this too, because I forgot to turn those on. But can I point out which are the satellites in the photo? Well, we actually don't have one. In the last, we don't have one currently in this one. In the last one, there was just a streak of light that went through here, and that's just because the satellite, when the exposure is being taken, is moving across, so it looks like a streak of light instead of a point of light like the rest of the things that are in here. So far, we haven't been photobombed by another satellite yet, but could happen any time, especially with Mr. Musk putting up satellites like he's a Pez dispenser, trying to bring satellite internet to everybody, and meanwhile amateur astronomy is going down the tubes because we're not going to be able to get any images without a bunch of streaks in them. Anyway, another story. Okay, so this was 16 seconds. Again, not a whole lot different, but just a little bit different from where we were before with the 30. So now, let's end that stack, and now let's go to 8 seconds. And I do have a dark for 8. I don't know that I have a dark for 4, but anyway, we'll see where we go. Okay. I'll restart the stack, get rid of the one at 15 seconds, and see what this... and see what we get here. Okay. Now we're definitely starting to shrink away with some of the outer stuff. Definitely starting to get a little bit smaller. And the core again is getting a little bit smaller. We'll give this just a minute or two, and then we'll drop it to 4 seconds. And then 2 seconds, and then maybe even 1 second. And at that point, we should really begin to see the stars that are at the core in the formation area. Let's just drop it to 4 seconds. Let's just drop it to 4 seconds. Bonk. Reset. Clear. Of course, every time I do this, I have to readjust. And now the histogram peak is going to be off the left edge of the scale. So, but that's okay because we're not worried about the faint stuff at the periphery anymore. We are just going to be working on those core stars here eventually. And when that happens, We don't really care about the histogram peak anyway, we just need to look at those bright stars. So now we're definitely losing a lot of size, off a lot of mass off the outside. The core continues to get smaller, starting to pick up individual stars in here. And just go for a couple more frames. Alright, let's go to 2 seconds. Let's do 2 seconds. And I'll start, in fact, zooming in a little bit. Since we're getting much smaller, and this core is getting much smaller, starting to pick off individual stars in here, but still pretty bright. And again, my internet just like took a quick bomb there for a couple seconds. But anyway, here is, that's at 1 second. Is that one? No, that's 2 seconds. Okay, let's drop to 1 second. Okay, now we're really getting small. And now we're starting to be able to pick out the individual stars in the interior, in the core interior. So you can see there's a little clump right there. That's probably the trapezium in there. But you can see we've lost a whole lot of the rest of it, because that's all too faint to show up now. And now we're just really going to be focusing and just barely start to make out the stars that are in there. Alright, half a second. Clear this. Aha! Now we're in. Now this the trapezium here is actually, you can now begin to pick out individual stars in here. In fact, I think we're seeing about the core 4 here. Now, I don't have a refractor. Yeah, Frank, that's a good point. I could also lower the gain. I don't know, but I was saying I don't have a refractor, so I don't really. Refractors are really good for picking out sharp images of stars. My imaging Newtonian is more of a light bucket. It's meant to really collect a lot of light and get faint fuzzy things. So image may not be real sharp, but I think we're getting enough to the point here that, let me try dropping the gain down. We'll leave it at half a second and try dropping the gain down. Okay, now there's a big difference. So now we've lost almost all of the nebula, but you're now seeing the individual stars that are the trapezium, that are in the very core there. And right now it's also not stacking. So what's happening now is that we're not stacking, and I think the reason is we're probably not getting any. Yeah, it's not. So what's happening now is we're not able to stack, and the reason we can't stack is because the image is so dark it's having trouble picking off enough background stars to actually align the image. So but for our purposes, we don't really need to do much of that anyway. Let's try lowering the gain again. See what happens. Reset this. Again, we're going to not be able to stack anything, but we'll at least get one image in. Yeah, see, now they're just really faint, and everything is really grainy. But that is what the Orion Nebula shrinks to eventually when you... So that's what you have to do to be able to see the inner stars, is reduce the exposure so much that you lose everything else. But you can pick off the stars. And that is the trapezium there. Which is right in the core. Right in the core of the star formation area. So, anyway... There you go. Let's put us back here to something normal. Knock that out. That will allow our stacking to resume again. And let's see. Should have everything back to about normal, I think. You're welcome, Carrie. Hopefully that kind of gave you a little exploration of the core. Oh, now I gotta put all this back. Change exposure levels and everything goes different. Yeah, and now we're kind of back to where we were. The Great Orion Nebula in all its splendor and glory. Oh, there we go, Christina. Right there. A photobombing satellite. Right through there. And actually, because this is in my southern sky, there's a little bit of air traffic in that area as well. So sometimes you'll see a plane go through there, but... definitely a satellite there. And as I continue stacking sub-exposures, it will continue to fade and fade and fade. As the subsequent sub-exposures don't have anything there, so the software says, well, it was dark in this one, so darken it. And then it was dark in this next one, so darken it some more. And it was dark in the third one, so darken it even more. And eventually it would just fade away. Yes, so that's... exposure time. I mean, anybody who's done any photography, exposure is exposure and gain, or I believe in camera parlance, the gain is ISO. But yeah, they all affect what you can see. And with astronomy, we've got some things that are really bright and some things that are really faint, and you have to adjust your exposure and gain levels accordingly. Now, speaking of more faint, we'll do the lower sword next. So that was kind of the big deal there. Let's move to the lower sword. And this is just a much smaller cluster that has some nebulosity in it. Whoop, 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 whoop. Yeah, see, we've still got M42 up here, so I may actually try and move that down a little bit. Let's see. Or I'm sorry, move it up out of the frame so we're not quite blowing out so much this bottom part. It's still going to show up because it is so big and bright and spectacular, but I'm actually even going to try doing a full 60-second exposure on this and see how that comes out. We may just get a whole bunch of bright noise from the M42 above it, but we'll see what comes out of this. Good question, Carrie. The horsehead with my rig. Well, I'm going to answer that. Well, we will see. You will have your answer here probably within the next 10 minutes, because I think that's probably where we are going to go next, is horsehead and flame. Since we're doing all the big, bright, spectacular stuff in Orion tonight, which which is nice and high overhead. Although, it looks like we might be a little fuzzy with cloud right now. And maybe a little bit of high, thin, wispy cloud moving in. So that may, and I think that's probably what all this fuzziness is. It is. Things have gone a little fuzzy here in the last few minutes, and I'm just looking up at Orion, and I think we've had a little bit of high, thin cloud move in the southern sky. So, we may actually take a brief respite from the southern sky and swing around and do something in the northern sky just so it can clear. So I may have just lied, Carrie. We may have to wait a few minutes, because you can see here from the bottom, this is the bottom star in the Orion Sword, which is this cluster that does have some nebulosity associated with it. However, it's got a little more nebulosity than normal because it's we're trying to shoot through a little bit of high thin cloud right now, which they said was probably going to happen tonight, but we will definitely come back. May just have to find something else to look at in the meantime. But yeah, I've definitely got, this is why this is all fuzzy in here. Definitely have some well, let's figure out what else we can go look at. We could go do the well, we could go do Pleiades. Yeah, well, I don't think Pleiades is far enough north. I think it also is in the cloudiness, but hey, it's one of those things that won't necessarily look terrible in the cloudiness, so we'll just go check it out anyway. So, yeah, let's do that. Let's go check out our Pleiades. Let's try and move a bit north in the sky, just to a bit further north in the sky. Oh, you missed it. It's over here. Yep, there's our Pleiades. Okay. Let's go ahead and move over there, because I think that's got a little bit more of a clear sky in there. And this is another nice big bright thing. That's a lot of fun. Let's just fire it up. Start imaging, profile, reload. Hey, Kenton! Nice to see you on. Thanks for joining. Oh yeah, Carrie, my folks are on the East Coast. They're in New England, and they were saying today the wind was just shaking the house, and it had a high of like 17 today. So, crazy weather out there. Alright, let's see if we can the Pleiades look. But yeah, I definitely have a little bit of just a really high, thin layer of cloud seems to have moved in to the southern sky. So we'll try moving around and doing some few other things in other spots of the sky and give that a little bit to clear up. But then, yes, it is absolutely my intention, Carrie, to come back and yeah, you know what? I want to reposition this. So let's I want this further up. So let's move it a bit to the left. And move it up in our image a little bit more so we can see some more of that stuff. Yeah, there we go. That's nice. That's about right. Alright, let's try it again. And it's definitely going to be fuzzy. It's definitely going to be fuzzy because we do have a little bit of cloud. But these are a big bright thing that'll actually be kind of okay fuzzy. So but they're pretty darn nice. The nebulosity in these is really cool. And I think these are a little bit further away. You can see there's a lot of nebulosity in this stuff too. But let's see, let's type it in M45, which is what? Oh boy. Okay, you don't want to put M45 as a search into Wikipedia because all you get is a bunch of military vehicles. Alright, well there we go. There's some of that nice brightness. You can kind of move that in there like that. Let's see how much we can resolve. We definitely do have some high thin cloudiness that's kind of mucking things up, but Pleiades, Seven Sisters, an open star cluster, middle-aged hot B-type stars. It is among the star clusters nearest to Earth. It's the nearest Messier object to Earth, and is the cluster most obvious to the naked eye in the night sky. Cool. Computer simulations have shown that the Pleiades were probably formed from a compact configuration that resembled the Orion Nebula. Astronomers estimate the cluster will survive for about another 250 million years, after which it will disperse due to gravitational interactions with its galactic neighborhood. All the stars have formed within the last 100 million years. But they call them middle-aged hot B-type stars. Well, I guess hot B-type stars don't live very long. The bright blue hot ones tend to not do so because they are figuratively burning the candle at both ends and burn through their fuel pretty quick. Whereas normal sequence stars, like our star, our sun, that are more along the yellow and orange color spectrum, they burn much cooler and burn much longer. Our sun will live, well, it's already been around for about 5 billion years and will probably go about another 5 before it goes through its main sequence ending, which generally means it burns through its fuel. It burns through all of its hydrogen, I believe it is, and the only thing it has left is helium, and it starts burning helium, and it's much hotter, and so it expands and turns into a red giant. And when that happens, it will probably expand even to the size of the orbit of the Earth, or even larger. So we have 5 billion years to figure out what we're going to do. But and then it will expand. It will just continue to expand outward, and it will probably form a planet, what's called a planetary nebula, where its core, which will probably be a brown dwarf, will continue to burn and will light up, will fluoresce, will illuminate the gases that are being blown out from it when it was burning helium, and it will create what's called a planetary nebula. And so that's what a main sequence star does, a more yellow star like ours. But these hot B-types, they burn through much quicker. They've only been around 100 million years approximately, and they're already called middle. They're considered middle-aged for these type stars. 100 million years. When our sun was 100 million years old, gosh, it probably hadn't even formed our solar system yet. It was still a very young one then. Well, let's see. What else can we take a look at here? Move around into the northern sky a little bit more. So what I'm using here is a planetarium called Stellarium, and it's a free open source planetarium that has a great interface, and one of the reasons I really like it is because it can also control my scope. So I can pick an object in here and hit a hotkey combination, and it will send the scope wherever I point it. Let's see, this is the owl, I think. Yeah, that's owl. Well, the owl is so we can, yeah, actually that wouldn't be bad. We were just talking about planetaries. So maybe we'll go check out the Owl Nebula next, and go check out a planetary nebula. So that'll be next. It's in the northern sky, and away from these pesky clouds that have moved in a little bit on the south. So we'll go check that out. But the Pleiades, yeah, you can't. There is definitely, you can see some. There is definitely some nebulosity in here, but it's hard to distinguish from the fuzziness due to the clouds. So it's pretty, but it's not as pretty as it could be. The clouds, unfortunately, are kind of fuzzing things up a bit. It usually looks a lot nicer than this when you can actually distinguish the nebulosity from the fuzziness of the clouds, but in this case, yeah, this is just going to blow it out. So let's go over and check out the owl. Alright. Next target. My haltingly, partially broken scripts in the beta software. Let's go check out the owl. I think I already had it selected, didn't I? Yeah. Okay. Yep, the scope's going to have to swing all the way around the long way. Going from western sky all the way over to northeastern. And like a lot of like all the things that are in this area when it's so close to Polaris. Here is Polaris here in the Little Dipper. This is where pretty much the whole sky rotates around this. And so all the stars within 20 or so degrees, 25, 30 degrees or so of Polaris are called circumpolar because they never set. No season are they actually setting. So this is one of the circumpolar objects. It's M97 too. It's actually one of the Messier objects. So that's cool. Let's see if I can find this without doing a plate solve. Now, normally my sequence does this, but I'm going to have to do it manually tonight since the sequences are broken. Let's see. These three bright stars should be in here. I'm not seeing them. So... Alright, let's see if my... let's see, I don't have the... Well, let's see. I think I still have my plate solving software set for my 183, the other camera, so we'll have to see if this actually solves or not. So far, not looking good. So what the plate solver is doing is it actually takes a picture of the sky, and it then goes into its catalog. Yeah, too few. It's saying it's too few stars. I need to kick up the... It actually finds in its catalog, it has a catalog of all of the... oh, you can see it right here. There it is right there. Just by increasing the exposure, I was able to find it. Oh, and it solved too. So it's just going to basically move this up into the frame here. It actually compares the image that you took with all the images of the sky in the area of where it's supposed to be, and says, oh, you're wanting to be pointed here, but you're actually pointed here. So then it does exactly what you saw it do. It automatically repositions the mount to put your object right in the center, which it's done here. So plate solving is very, very cool stuff. Okay, so let's see what we can see with the Owl Nebula. Been a while since I've done the Owl Nebula. In fact, let's take a look and see. It's M97. How far away is it? About 2,000 light years, so not too far away. Alright, let's type in M97 here and see what Wikipedia has to say about it. Messier 97. And the Messier list, for those who don't know, was created by an astronomer named Charles Messier. He was a comet hunter, 19th century, I believe, and he would scan the sky for comets, and he kept running into these bright objects in the sky, and he kept running into the same bright objects, and they were obviously not comets, but he kept running into them. So what he wanted to do was create a catalog of objects that were not comets, because he was a comet hunter. He didn't care about other things. He wanted to hunt. Well, it looks like the internet kind of bombed out again there. So interesting. Well, I can't tell if... Well, now it looks like we're back. Looks like the internet bombed out again real quick. So it was down for about a minute and then came back. Anyway, it looks like I'm back. Hopefully I haven't lost any of you. Anyway, Charles made this list of things that were not comets, and in doing so, his list was about 300 items long. 103 items long. And in subsequent years, researchers have discovered that he found several other objects as well in his notes, but he never actually added it to his formal list. But they added them since then, so now it's up to 110 objects. And he unwittingly ended up making one of the list of one of the most brightest and most spectacular objects in the sky, and it's called the Messier list. And so you'll often hear astronomers refer to things as M this or M that, and it's because this was one of the objects that Charles Messier actually found and put in his catalog, put in his list of things that were not comets. So here is M97, and this is a planetary nebula. And again, we still have some. You can see there's a lot of fuzz. So even in the northern sky, we have some high thin clouds. So unfortunately, we may just be stuck with this tonight. And see the Owl Nebula here, and this is a planetary nebula. Let's check the color levels here. Yeah, color's a little bit whacked out. Let's go up a couple on the on the blue. But this is actually a planetary nebula, and so this is what is likely to happen for our own main sequence star, the Sun. And it looks like my internet is gone again. So, yeah, my ISP must be having problems, because the internet is just going up and down and up and down. The connection to my router is good, but going all over the map. So, oh well. Not much to be done about it. But this is what's going to happen to a main, probably to our Sun. And again, it converts to burning helium, and so it expands really fast, and then it blows its outer gases, its outer layers, and as they blow away, the middle part of the nebula continues. The middle part of the star, but it's still glowing. So, I'm not really sure what's going on with the internet tonight, but definitely having some problems with it. It seems to come back and be stable for a while and then goes through these fits. So, not sure what's going on there. But anyway, I seem to be back. Hopefully you guys are back. But here's the Owl Nebula, planetary nebula. And the planetary nebulas obviously have nothing to do with planets. They were, when they were originally discovered, the astronomers back then did not have telescopes nearly as powerful as ours now. And so they could tell that they were obviously disks, that they obviously had some shape to them like a planet, and they might have even been able to detect a little bit of color to them. So they knew they weren't stars, because stars are always point sources, no matter how much you magnify them. They're always just points. The reason in images they look like disks or circles, like you see in this image here, is because they're so bright they're actually saturating. The light is actually saturating surrounding pixels, and so the longer you sit and expose on them, the bigger around a star will get. But that's just because its bright light is saturating surrounding pixels in the image. It's not because they actually have any shape. Stars are so far away that we can't actually see any shape in them. But with a planetary nebula, you can obviously it's much bigger, and it's oftentimes much closer. So we can actually see some shape. It's definitely had a disk to it, not just a point. And so they knew that they weren't stars, and they kind of looked like planets a little bit, so they got named planetary nebulas. And the name has stuck, even though it's obviously has nothing to do with planets. It's the death process of typically a main sequence type star, like our Sun. What our Sun will be doing in about 5 billion years or so. Ooh, and we're in luck, because this has given us enough time that the sorry, an alarm was going off somewhere. This has given us enough time that the southern sky has re-cleared. So, we'll take another minute here on the Owl Nebula, and then we're going to head back over and head back to our Orion. And in this case, like Carrie asked, we're going to go check out the Alnitak area and Horsehead and Flame, and answer his question of whether I can see Horsehead or not. So we'll do that right now. And that's the end of the Owl Nebula, which is fuzzy as well because the clouds are up there now. So we will next target. Alright. And let's head back around to right there. Poink. All in attack. Come on. No, not you. All in attack. Boom. Alright. So you can see I can just click on something and hit a key combination in my Planetarium and it'll just send the scope right there, which is very cool to be able to do that. An Alnitak is the left-hand star in the belt of Orion. And there's a couple of really cool things here, one of which Carrie was just indicating. And so, well, actually, you know what? I might not want to go over there too far, actually, now that I think about it. Because they're going to be all right in there. So, yeah, actually, this is probably about right, actually. Let's go ahead and just start imaging reload profile. Hopefully, we'll get these bugaboos fixed that are currently in here. I talked to the developer today, and he says that I should be able to just reload things and it should work, but I'm not seeing it. According to him, I should be able to just reload these things, and it should. Come on. Next target, start imaging you. Yeah. See, I get no way to enter data in there. So, let's try. Let's just try real quick if I can put it in here. Set control name. Well, this is more promising, actually. Black point. Property value. 0. Yes, good. Well, maybe he's right. Get rid of him. Midtone. Right? Come on. Oh, you know what? I think I just screwed that up. Yeah, okay, set 0, 0.5, and 1. Let's see how we're doing here. Okay, up here, there you go. Display black point, 0, good. Okay, and then you are going to go there, and then you are going to go there, and this is going to be display mid-tone, and it's going to be 0.5, and this one is going to be display white, point to 1, so that's already in there. Okay, so that should now work. Save. Well, anyway, let's see what we got here. Okay, so wow. Okay, we're going to reset the stack because apparently the scope was still moving. So we're going to reset that. Because the scope seems to have not been settled. When it started on that image. Let's see how this looks. This should look better. There we go. That's a lot better. Okay. So this, that big bright star that you're seeing in there, that is Alnitak. That is the star at the left of the belt of Orion. 2 ticks there. And down here, you'll see what Carrie was asking about. And that is the Horsehead Nebula. Let me get this adjusted right again. Okay, there we go. That is the Horsehead Nebula. This is Alnitak here. And this is the Horsehead Nebula down here in this hydrogen region. Hydrogen is red. This hydrogen gas region. And this is the Flame Nebula up here. And so these are 2 really cool things that are in this region of, again, a very active star formation region that is in Orion. There's just so much bright, pretty stuff around here. But this is Flame and Horsehead. And we could take some good time here to really let these settle in. The clouds have moved on, so the sky is nice and sharp back there again. So we should be able to resolve these pretty sharply and pretty well. And it looks like, getting a little hourglassing there on the... Getting a little hourglassing. But it looks like, well, the connection continues to be kind of wonky. So we'll just leave it be for the time being. And trust that it will keep coming back. So far it has come back every time, so it's just gone for a short, brief little stint, and then it comes back, so... Let's see what Wikipedia has to say about the Flame Nebula. Because I know the Horsehead is in the red is hydrogen, but I'm not sure. Well, let's see what is said here. It's an emission nebula in the constellation of Orion. And emission means there are reflection nebulae and emission nebulae. And reflection nebulae basically is gases, stellar gases, that are reflecting light from a light source, typically a star, that's very nearby. An emission nebula is a cluster of gases that is actually being excited by radiation of some kind, perhaps from a star or some other radiation source, and it's actually being excited and actually emitting its own light because it is actually being excited by some sort of radiation that's getting it all excited. And so this, in this case, this is the Flame Nebula. The pale colored Flame Nebula up here is an emission nebula. It's approximately, well, let's say 900 to 1500 light years away. Basically, Alnitak itself, they're saying, is shining ultraviolet light into the flame, and this knocks electrons away from the great cloud of hydrogen gas that resides there. Much of the glow results when the electrons and ionized hydrogen combine. So the electrons and ionized hydrogen are combining. Additional dark gas and dust lies in front of the bright part of the nebulae, and this is what causes the dark network that appears in the center of the glowing gas. And that's true for a lot of nebulae, anytime including with Horsehead here. This is dark dust, a clump of dark dust that is in front of this nice red hydrogen area of nebulosity, which is probably also emission. But this is just a dark area of dust and gases that are over the top of it that makes it look like there's a cutout in there, but typically what happens is it's an overlay. One dark nebula overlays a brighter, more colorful nebula in the background, and you get these interesting shapes. The Horsehead down here and the flame up top. Let's see what else they say. The Flame Nebula is part of the Orion Molecular Cloud Complex, a star-forming region that includes the famous Horsehead Nebula that we're also seeing in this image here. At the center of the flame is a cluster of newly formed stars, 86% of which have circumstellar disks. X-ray observations by the Chandra X-ray Observatory show several hundred young stars out of an estimated population of 800. X-ray and infrared images indicate that the youngest stars are concentrated near the center of the cluster. So there's a cluster in here of stars too. Probably too small for me to see with my scope, but my scope is good at picking off larger, faint, fuzzier objects like the whole thing here. But there's a star cluster in there of about 800 stars, they're assuming. I'm going to let this build for a minute while I go in and throw a jacket on, because I haven't needed a jacket actually up to this point. It's been kind of nice, but now it's starting to cool off a little, so I'm going to go get a jacket on. I'll be right back. Okay, that's warmer. Jeff, you got your you got a little imaging newt like mine, huh? They're fun little scopes. They really work well. The bang for the buck on these suckers is really good. I've enjoyed using mine a lot. Let's see. You know what? Come to think of it, though, we spent all this time on it, but actually, I could brighten that up by quite a bit for you guys, so that you can see it a little bit better. I keep forgetting I have to really stretch it at my end so that you guys can see it well at yours. Oh, you had to go all the way to Germany to get it. Whoa. Really? So was this a specific special kind of 6-inch f4, or just a run-of-the-mill and nobody has any stock anywhere, which is just part of the pandemic fun? Yeah, again, this the quality of the image once again has to go to the camera. It's these 533s are really amazing. They're packing a lot of dynamic range and sensitivity into the newer crop of sensors, and it really does fabulous. Even the faint little details are very sharp, and but yet it can manage the blinding brightness of AltAz as well without blowing the whole image out, which is a problem when you have with any sensor. When you've got a really bright object and a really faint object in the same image, you got to have a pretty good sensor or pretty good software dealing with it to try and get everything to play happily. And these 533s are really good. I'm very happy with mine. But this is one of the most spectacular regions of the sky. M42 is certainly big and bright and beautiful that we were on earlier. The Great Orion Nebula is definitely pretty nice. But this actually, I think, is my favorite image. Just different textures and colors going on, and I think it's one of my favorites. So there were just none in the US, huh, Jeff? Yeah, that's getting... astronomy has become very, very popular this last year or so. Hard to get anything. Prices on the used market even have gone up by 30% to 50%. I can't believe the prices for used stuff that I've been seeing for the last 6 months. Just everything has gone up and up and up because nobody has any stock. So yeah, again, my internet connection seems to be pretty stable. You can see a lot of nebulosity around almost every big bright star in here. The smaller ones not so much, but any of the bigger, brighter stars has nebulosity around it. Because it's just there's just so much gas and dust in the whole Orion region, and it's all coalescing and forming all those little stars. But this is a nice object to spend a little time on because it really comes in nicely. It really can stand to have the extra time. While that's doing that, we can kind of figure out where we're going to go next. I suppose we could go see Casper. Haven't seen Casper in a while. And we'll do that. And whoops. Wrong button. I hate it when I do that. Wrong button, wrong button. We'll give this another minute or so, and then we'll go see if we can see Casper up there. Well, that's about 16 minutes of data there. Total time 16 minutes. So Carrie wants to know my image settings, exposure, gain, and such. So right now with the 533 I'm using a gain of 300. The exposure time is 60 seconds in this case. Pull the panel in here so you can see it. Yeah, 60 seconds, a gain of 300. I am running darks and flats for these exposure times. Oh, and it looks like my internet is going kaflooey again. Wild. It's with this. I've got the camera set for negative 10 degrees, but I'm not sure that's not a huge factor with EAA when you're doing relatively short exposures. Even 60 seconds is cooling is, you know, what cooling does is kind of marginal. Yeah, so that's what I'm using for this with the 533. And again, my network is kind of going all over the map again. I'm not sure what's happening, but yeah, I'm going I'm going all the way down to 0. So definitely something weird and wonky going on with my network. But anyway, there's that's 17 minutes. So let's go. That's pretty good for that one. Let's go ahead and oh yeah, I can actually fix my thing now. So this one is now fixed. I already saved that. So let's fix my other one so it doesn't keep erroring out, which is next target 533, which needs to, yeah, this one here said midtone point is 0.5. I gotta do that one. Come on, hello. Okay, set midtone point to 0.05. Very good. Save. So now this should also work correctly. Alright, so moving on. Next target, 533. Yay! Look at that, it worked. Okay. And let's go and check out Casper. Haven't seen Casper in a while. Haven't seen Casper in a while, so let's go do that. Yeah, there's that little Casper over there. Okay, let's back this off. Bring you back a little bit. Come on. Oh, what do we got? Ooh. And we got a little bit of a software hang. There we go. It is complaining, but it does... Uh-oh. Where are you going? Where are you going? Whoa, whoa, whoa. Whoa, whoa, where are you going? Software going nuts here. Come on back. Jeesh. Yeah, I don't know. This definitely got some weirdness going on, and I've just uninstalled and reinstalled it, so I know it's all Come on. Stop walking. I gotta lay this. Okay, there we go. Stabilized. Good. Okay, and now we will start imaging. I can use the regular one because now alright, well, now they all work. Yay! Let's see what Casper does. Well, that's coming in. Well, that's coming in the first time. So now we're up right on the side of Orion over here. But again, still within the Orion area where there's a lot of nebulosity and things. So, and again, my internet is just going to zero, plunging to zero, and then coming back, and plunging to zero, and coming back. Craziness. Okay, we need to do a little histogram adjustment since this is a much dimmer object. But the clouds have stayed away, so that's good. We get some nice sharp sky. And as this continues to come in, we'll get some more so, apologize for the network issue, the internet issues. I'm not sure what the heck is going on with the internet, but it's all up and down. Now, once this, you watch in a few seconds, as the second sub-exposure comes in, the whole background will darken. Right about now. Boink. So that was the second sub-exposure being added to the first, and reducing a whole bunch of noise, and the second sub-exposure is saying, okay, this background should be darker, so it makes it darker. And then when the third one comes in, it'll do it again, a little bit less pronounced, less dramatic, but it will still reduce the noise even more. It makes the dark parts darker and the light parts lighter. And but this is Casper, which I believe is a reflection nebula. Let's see, M78, another Messier list item. M78, boink. Messier 78. Yeah, it is a reflection nebula. It's in the it was discovered by Pierre Merchant in 1780 and included by Charles Messier in his catalog of comet-like objects that same year. Oh, Charles Messier was that far back. Messier was the 18th century. Okay. Thought he was 19th, but nope, he's 18th. M78 is the brightest diffuse reflection nebula of a group of nebulae that includes NG 2064, 2067, and 2071, which I think are all these surrounding pockets of light. Let's zoom in and find out. Yeah. So 2071 up there. Yeah. So all of these various pockets of light are all this complex. Orion B molecular cloud complex, and is about 1,350 light-years distant. M78 is easily found in small telescopes as a hazy patch and involves two stars of 10th and 11th of magnitude. These two B-type stars are responsible for making the cloud of dust in M78 visible by reflecting their light. And I assume that is these two stars right here, which are the two, basically the eyes in here of Casper, I guess. I don't know where Casper is in there, but anyway, I assume these are the two B-type stars that are actually reflecting all the light off the gas and make it glow. M78 cloud contains a cluster of stars that is visible in infrared. Due to gravity, the molecular gas in the nebula has fragmented into a hierarchy of clumps, the denser cores of which are about to form stars. the denser cores of which about to form stars with masses of up to 5 capital M. About 45 variable stars of the T Tauri type, young stars still in the process of formation. So, like so many of the other areas of Orion, this one is also a star formation area. Just a hotbed of star formation here. Network is still all kinds of freaky all over the place. It's up for the moment. Yeah, it's up, it's down, it's all over the place. Goes from full speed to 0 to full speed to partial speed to pretty kind of whacked. I think this is probably going to be my last object anyway for the night. I'm gonna need to figure out what yeah, hopefully it's looking like right now maybe Thursday night might be the next night. That's the next possibility for weather, so we'll have to see. Hopefully my internet connection will be more stable. I'm not sure what's going on with my ISP, but hopefully things will be more stable on Thursday night, or whenever next. Because it's been pretty wacky tonight. But anyway, hope you guys have seen a few things of interest. It was kind of fun doing M42 at all the different exposure settings, shrinking it all the way down to the trapezium, the cluster of stars at the center. That was kind of fun. And finishing off with Casper. Give him another minute or two here. There are some pretty interesting, some of the dark dust lanes in here do make it kind of interesting to give it some interesting shapes. Let's push the stretch here a bit so you guys can see it a little better. Yeah, I can tell by how herky-jerky my my progress bar is on the stream that I'm watching that my internet connection is definitely spotty. Hopefully I'm sounding okay at least. Usually the audio they carry through pretty consistently, and the video is what gets spotty and intermittent. But well, thanks, Gary. I'm glad you were here. Glad you got some good stuff out of it. And yeah, it's fun. I like doing this stuff. So, and there's some pretty spectacular stuff up in the sky if you just know where to look. So, I think I'm going to take my semi-crappy network and call it an evening. But thanks everybody for joining. Really appreciate it. And like I said, possibly Thursday night right now is looking like the next possibility. So we'll have to see. But anyway, ISP just fails completely. It looks like I'm pretty much on 0 right now. So anyway, good night everybody. Thanks for joining, and